In this video, we will go over the operation of a drill. Before getting started, confirm proper protection equipment, or PPE. The three main parts of a drill is the power drill itself, the drill bit, and the battery. The tip of the drill bit has the cutting edge. Notice that the end of the drill bit isn't flat. Instead, it has an angled edge. This angle helps with the cutting action. Zooming into the cutting edges, you'll also see two spiral grooves, also known as flutes. The flutes allow chips created during drilling to exit the hole. The part that the jaws of the chuck grips onto is called the shank. To use the drill, you'll want to place your dominant hand on the rubber handle in the middle. Your non-dominant hand goes on the back of the drill's head, applying downward force. Then, use your index finger to press the trigger. This is the forward and reverse switch, which also acts as a trigger lock. When the forward arrow is pushed, the drill bit will rotate clockwise, allowing you to drill into the material. When the backward arrow is pushed, the drill bit will rotate counterclockwise. This is useful for removing screws. When the switch is centered in the middle, the drill is locked, and the trigger won't activate. Always make sure the drill is locked when not in use. At the top of the drill, you'll find the speed selector with two options, 1 and 2. For our purposes, we'll keep it at 1. Next, you'll see a small arrow pointing to the current setting for both the clutch and mode selector. Rotating the clutch allows us to change the torque of the drill. The torque ranges from 1 to 20, but we'll keep it at 10 since midway is a good starting point. This mode is the hammer drilling mode, which is used to drill into masonry, like concrete. The drilling mode, to drill holes, and the driving mode, for inserting and removing screws. However, we will mainly be using the drilling mode. This is the chuck, which allows you to adjust the jaws that hold the drill bit. To know whether you are closing or opening the jaws, look at the chuck and use the right hand rule. As you twist your hand clockwise, your thumb points towards the chuck, showing that the jaws are closing. To close and lock the drill bit in place, rotate the chuck clockwise when looking at it from the front. This will cause the jaws to tighten around the drill bit. To open the chuck, rotate it counterclockwise when looking at it from the front. As you turn the chuck, the jaws inside will expand, allowing you to insert or remove a drill bit. When inserting a drill bit, start with the chuck jaws slightly smaller in diameter than the drill bit itself. This helps ensure the drill bit stays straight as it's locked into place. To properly secure the drill bit, rotate the chuck clockwise. You'll often hear clicks. After tightening, give the shank a gentle tug to confirm it's locked in. Finally, push the prepared drill into the battery. Here we can see that the battery is correctly inserted and the drill can be powered on. This is a drill bit set, organized with drill numbers on the top row and their corresponding diameters in decimal equivalents on the bottom row. So if you look at the top row, a number 40 drill bit, for instance, has a diameter of 0.098 inches, as shown on the bottom row. A drill size chart can also be used to find the corresponding drill number for a specific diameter. As you can see here, the left column of the chart shows the drill size by number or letter, and the middle column provides the decimal equivalent in inches. On the sides, you'll find the letter and fraction drills, which are typically larger than the drills on the lid. The letter drills range from A, the smallest, to Z, the largest. As we look at the fraction drills, notice the half-inch is the largest drill bit in the set. To measure a drill bit's diameter, we can use a caliper. The caliper's jaws should be positioned on the consistent diameter nearby the cutting edge. In this case, we know that the drill bit is 11/64 of an inch, and the caliper confirms that. This is a clamp which holds down workpieces. To open the clamp or make large adjustments, hold down the small black lever. To fully secure the clamp onto the material, squeeze down on the larger black lever. When clamping the workpiece to a table, ensure that there is a 2 to 3 inch overhang between the table's edge and where you plan on drilling the hole. This prevents you from accidentally drilling into the table. To ensure a stable work area, always clamp down the workpiece Using only 2 clamps near the front can cause wobbling, making power tool operation unsafe. To prevent wobbling, use a third clamp towards the far end of the workpiece for maximum stability. Once clamped, always test the setup by applying body weight to the overhang. If the workpiece remains firm, it is safely secured. Before drilling, always make sure the drill bit is long enough to reach the required drilling depth. Prior to drilling, always make sure that the drill bit is perpendicular to the surface. Drilling at an angle can make it very difficult to re-drill or correct the hole later. With the proper orientation established, press the trigger. Apply force along the axis of the drill bit using the non-dominant hand. While drilling, the material will provide a feeling of resistance. However, after breaking through the material, the tool can easily progress too far, which would cause the chuck jaws to scratch the workpiece. Immediately after completing the hole, keep your finger on the trigger so the drill is still spinning as it backs out of the hole. To drill a specific depth, such as 3/8 of an inch, use a caliper to measure and mark that depth on a drill bit with tape. This visual cue indicates when to stop drilling. Ensure the drill bit is perpendicular to the surface. Drill only until the bottom edge of the tape touches the wood. To measure a hole's depth, use the end of a caliper. This is the thumb screw. As the thumb screw is rolled, the gap between the jaws of the caliper increases, and a thin bar extends from the back. Use this bar to accurately measure the depth. First, extend the caliper to more than the expected hole depth. As it lowers into the hole, the bottom of the hole should push the bar back up. When drilling into thick material, excess wood chips can build up inside the hole, preventing deeper drilling. If this occurs, remove the drill bit to clear the debris from the flutes. It is common to use a painter's brush, but in a pinch, gently tapping with a plastic or wooden pencil will work. Once the flutes are cleared, continue drilling. This is a flat paddle drill, which is one of the options for drilling holes larger than a 1/2 inch in diameter. When using a paddle drill, first align its pointed end with a mark and make a small indent in the wood to help guide the drill. Then, apply constant downward force to the drill and continue drilling until passing through the material. Right after breaking through the material, immediately back the tool out of the hole to prevent chuck jaws from scratching the wood. These are the tools we will be using: a flat paddle drill, a small diameter drill bit for making a pilot hole, a medium diameter drill bit for making a clearance hole, and a large diameter drill bit for making a countersink. The smaller diameter drill creates a pilot hole that guides following drills, ensuring all holes are aligned. The drill's diameter matches the screw's root diameter, or the smaller diameter between the threads, which helps prevent the root diameter from splitting the wood. Since this drill is very thin, caution is advised as it can flex and snap. The medium diameter drill creates a clearance hole with a diameter slightly larger than the screw shank and threads, but smaller than its head, which prevents the shank from splitting the wood. The tip of the large drill bit will create a conical hole, called a countersink. This readily available drill bit is being used to approximate a specialized countersink tool, so that the flat of the screw will sit flush with the top surface of the wooden part. Now we will be assembling these two wood pieces together using the drills just discussed. First, ensure all workpieces are held securely on the table using clamps. Next, mark the drill's depths. For the pilot hole, mark the full length of the screw. For the clearance hole, mark the depth of the component that will be compressed by the screw's head. Now, to begin drilling, start with a pilot hole. As observed, resistance may occur due to wood chip buildup, meaning the drill must be backed out to clear them. After clearing the chips, return the drill bit to the hole and drill out further until the tape touches the surface. Then, move to the clearance hole, again retracting when the tape touches the surface. Next, to create the countersink hole, this drill bit can be used as a replacement for a dedicated countersink tool by drilling only the depth of the angled tip of the drill bit. Finally, Take the screw and insert it into the hole, where it should pass through the clearance hole and stop at the pilot hole. When you see a large plus indent on the screw head, use a Phillips head size 2 driver bit. Remember to switch the mode selector to driving. Apply constant pressure until the flat of the screw head is flush with the top of the material. When the screw is spinning, it must be going forward or else the screw's threads will gouge the wood. If we need to drill entirely through a material but can't use an overhang, we'll place a sacrificial material underneath to protect our table. To ensure drilling to the correct depth, use tape to mark the proper depth on the drill bit. Since the drill bit's tip does not have a consistent diameter, position the tape slightly higher to account for the angled tip. Again, drill until the tape touches the top of the workpiece. It is expected that the angled edge will make a shallow hole in the sacrificial material below. As seen here, the drill successfully went through the material and created a hole with a constant diameter. Now we'll look at a few additional techniques. This is a hole saw, used to create holes 2 inches or greater in diameter. When operating this tool, it is beneficial to maximize the torque, maintain continuous drilling without stopping midway, and wedge the drill between the rib and forearm to prevent the tool from swinging. Finally, to drill into metal, mark the metal using a black Sharpie or a scribing tool. Then, place the metal over a sacrificial material and clamp it out securely. Next, using a center punch, tap its end with a hammer to create a small divot, which helps the drill bit stay centered. We know the drill has passed through the metal when there is less resistance and wood chips appear from the sacrificial material underneath. Notice how the hole has a constant diameter. Now you are ready for many future projects. Thank you for watching.